For you, I am with 21 problems. These are the 21 problems. They are all based upon alternating current. They are all IMP problems. They will help you for your 12th examinations, engineering examinations, and JEE examinations. So I request you solve these 21 questions thoroughly in your notebook along with me. Then you will be really benefited. I hope you will solve these 21 questions and give me your feedback. How do you find this video? So let's start today's video. Problems on alternating current. 21 IMP problems. Example number 1. A 50 ohms resistor connected to 220 volts 50 Hz AC supply. Find RMS value of current. Find total power consumed over a full cycle. Solution. First of all, let us draw the circuit diagram. This is a resistor connected to AC supply. Resistor value 50 ohms and supply is 220 volts and 50 Hz supply. We need to find RMS value of current. So first, IRMS equals to how much? Given is VRMS value, that is 220 volts, and R value 50 ohms resistance value. IRMS equals to VRMS divided by R, that is 220 upon 50. This is equals to 4.4 amperes. Therefore, IRMS equals to 4.4 amperes. Now the second part, to find total power consumed over a cycle. So we need to find total power over a cycle. Now the net power consumed is given by P equals to IRMS square multiplied by R. So P equals to 4.4 square into 50. So P equals to 19.36 multiplied by 50, which is equals to 968 watts. So power consumed over a full cycle equals to 968 watts. Example 2. The peak value of an AC voltage is 270 volts. Find its RMS value. Solution. Here the peak value of voltage V0 equals to 270 volts. We need to find out VRMS value of voltage equals to how much. Relationship between VRMS and V0 is given by VRMS equals to V0 upon root 2, that is equals to 0.707 into V0. So 0.707 and V0 equals to 270. This is equals to 190.89 volts. Therefore, the value of VRMS equals to 190.89 volts. Example 3. An alternating EMF of 50 sin 120 pi t volt is applied across a 60 ohm resistor. Find RMS value of current and RMS value of voltage. find frequency of applied EMF. First of all, let us draw the circuit diagram. So resistor R and E equals to 50 sine 120 pi t. Comparing E equals to 50 sine 120 pi t with E equals to E naught sine omega t implies E naught equals to 50 volts. E naught nothing but peak value of voltage. Now E RMS is given by E naught upon root 2, that is equals to 0.707 into E naught. Therefore E RMS equals to 0.707 into E naught, that is 50. So when you multiply this, you will get 35.35 volt. So we got E RMS equals to 35.35 volt. Now I RMS equals to E RMS upon R. E RMS is 35.35 and R value given 60 ohms. So divided by 60. This is equals to 0.589 amperes. So we have answered the first question, that is find RMS value of current in voltage. So what is the result? I RMS equals to 0.589 ampere. This is the first part of the result, and the E RMS value equals to 35.35 volt. Now the second part of the question, find frequency of applied EMF. So we have E equals to 50 sine 120 pi t. We had compared with E equals to E naught sine omega t, implies, now comparing the trigonometry part, that is sine 120 pi t is equals to sine omega t, implies omega t equals to 120 pi t. What is omega? Omega nothing but 2 pi f multiplied by t. So omega value 2 pi f. So 2 pi ft equals to 120 pi t. Both side t cancelled. So we have the 2 pi f equals to 120 pi. Pi also get cancelled both sides. So we get f equals to 120 upon 2. F equals to 60 hertz. Therefore, second part of the question, supply frequency F equals to 60 hertz. Example 4, an alternating EMF is given by E equals to 180 sine 100 pi t volt. Find frequency of applied EMF and period. Solution. EMF is given by E equals to 180 sine of 100 pi t. Comparing it with standard equation, E equals to E naught sine omega t, implies omega t equals to 100 pi t, but omega nothing but 2 pi f. So 2 pi ft equals to 100 pi t. Both side pi get cancelled and t get cancelled. We get 2f equals to 100. So f equals to 100 divided by 2 equals to 50. Therefore supply frequency F equals to 50 Hertz. Now the second part, period. Period, that is denoted by capital T, equals to 1 upon F, that is equals to 1 upon 50, that is equals to 0.02. Therefore, period T equals to 0.02 seconds. Example 5. A peak value of alternating current flowing through a resistor of 20 ohms is given by 30 milliamperes. Find voltage across resistor at time t equals to t upon 2, where t equals to period. Given, what are the given? R value equals to 20 ohms, and peak value of current, that is I naught equals to 30 milliamperes. Now we need to find out the value of voltage at small t equals to t upon 2, where t is a period. So E equals to, let us say, voltage, and this is equals to current multiplied by resistance value. Current is nothing but given by I naught sin omega t, because it is a alternating current is applied. Therefore, the value of alternating current is I naught sin omega t multiplied by resistance R. So I naught value given 30 milliamperes, and sin omega t, and R value equals to 20 ohms. This is E equals to, and the result will be millivolt. So E equals to 600 sin omega t millivolt. We know that there are the two formulae for omega. Omega equals to 2 pi f, this is the first formula, and omega equals to 2 pi upon t, this is another formula. Therefore E equals to 600 sin, in place of omega, 2 pi upon t into small t, result is millivolt. It is given in the question that find voltage across resistor at time t equals to t upon 2. So E equals to 600 sin 2 pi upon t as it is, but time is given by t upon 2 second. So here is a t upon 2. The result is millivolt. T get cancelled, 2 get cancelled. Therefore E equals to 600 sin pi. Answer is millivolt at what? At small t equals to t upon 2. But sin pi equals to 0. Therefore 600 into 0. Therefore E equals to 0 at small t equals to t by 2. This is required solution. Example 6. A capacitor of capacitance 2 microfarad is connected across alternating EMF of frequency 50 Hz. Find its reactance. Solution. Here C given as a 2 microfarad, that is 2 into 10 raised to minus 6 farad, and supply frequency 50 Hz. Capacitive reactance Xc equals to question mark. We know that Xc given by 1 upon 2 pi Fc. So that is 1 upon 2 pi 50, and C value nothing but 2 into 10 raised to minus 6. This is equals to 10 raised to 6 upon 2 into 3.14 into 50 into 2. So this is equals to 10 raised to 6 upon 100 into 3.14 into 2. On simplification, it gives us 1592.3 ohms. So this is the value of capacitive reactance. Example 7. Draw RL circuit and RC circuit and write down formula for impedance and power factor. There are the two parts. One is RL circuit, another one is the RC circuit. So in RL circuit there is a resistor, in RC circuit even there is a resistor. In RL circuit there is an inductor, in RC circuit there is a capacitor. Both are connected across AC supply. There should be a key. In case of RC circuit, even connected to AC circuit, therefore along with the key, call it as a E. This is R, it is L, it is R, and it is C. So these are RL circuit and RC circuit. After that, impedance. Impedance is denoted by Z. Here, in case of RC circuit, even impedance is denoted by Z. Impedance is nothing but the opposition present in case of AC circuits when resistor, inductor, or resistor capacitors are all the three RLC connected in a circuit, then opposition offered to the flow of current is nothing but called as a impedance. Let E naught be the peak value of EMF and I naught is the peak value of current in both cases. Now impedance is given by Z equals to E naught upon I naught. Here in the same in case of RC circuit, impedance is given by E naught upon I naught. Now in case of RL circuit, the impedance is also given by under root of R square plus XL square. What is XL? XL is nothing but inductive reactance. In case of RC circuit, Z is also given by under root of R square plus XC square, where XC nothing but called capacitive reactance. Where XL equals to omega L and XC equals to 1 upon omega C. Therefore, Z equals to under root of R square plus omega L whole square. Z equals to R square plus omega square L square under root. Z is equal to under root of R square plus omega square and L square. Whereas Z in case of capacitive circuit, RC circuit, here putting the value of XC, that is 1 upon omega C. Therefore, Z equals to R square plus under root of R square plus 1 upon omega square C square. Now the second part, that is the power factor. Power factor is given by cos phi equals to R upon Z, where phi is nothing but phase angle. Same in case of capacitive circuit. R upon Z. Here also phi equals to phase angle. Example 8. For following circuit diagram, find impedance and power factor. Here supply EMF is given by E equals to 20 sine 2 pi t. Comparing with standard equation, E equals to E naught sine omega t implies E naught sine omega t equals to 20 sine 2 pi t implies omega equals to 2 pi. After that, R equals to 20 ohms, L equals to 3 Henry. Now impedance, Z equals to impedance, Z equals to R square plus XL square, that is equals to R square plus omega square L square. R value 20, so 20 square, omega value 2 pi square, L value 3 Henry, 3 square. So Z equals to under root of 400 plus 4 pi square into 9. 400 plus 4 pi square value 9.85 into 9. On simplification, it becomes 754.6. Taking root, we get here 27.46 ohms. Therefore, impedance of the circuit is 27.46 ohms. Now, the second part is power factor. Cos phi equals to R upon Z. Cos phi, R value is 20 and Z value 27.46. This is equals to 0.72. Therefore, power factor equals to 0.72. Example number 9. An alternating EMF of frequency 50 Hz is applied to series RL circuit. Inductor of 0.3 Henry and resistor of 30 ohms. Find impedance of the circuit, power factor and find phase angle. First of all, let us draw the circuit diagram. This is resistor and it is an inductor. Both are connected across AC supply. They are in series, R and L. R value 30 ohms and inductor of 0.3 Henry and supply frequency 50 Hz. We need to find impedance of the circuit, power factor and phase angle. So to find the impedance, what is the formula? Z equals to under root of R square plus XL square. We don't have XL value. First we'll find out XL. XL is given by 2 pi FL, that is 2 pi supply frequency 50, L value 0.3 Henry. This gives 94.2 ohms. After that, Z equals to under root of R square plus XL square. What is XL? Inductive reactance. XL is inductive reactance. So inductive reactance equals to 94.2 ohms. R value 30. So 30 square plus 94.2 whole square. This is equals to Z equals to 900 plus 8873.64, that is equals to under root of 9773.64. After taking out square root, we get 98.86 ohms. Therefore, impedance of circuit Z equals to 98.86 ohms. After that, second part, power factor. Power factor equals to cos phi equals to R upon Z. Therefore, cos phi equals to R value 30 and Z value 98.86. After division, we get 0.30. So power factor is 0.30. Now the last one is to find phase angle. We have cos phi. Cos phi equals to 0.30. Therefore, where phi is a phase angle, therefore phi equals to cos inverse of 0.30, that gives 72.54 degrees. Therefore, phase angle equals to 72.54 degrees. Example 10. An alternating EMF of E equals to 230 sin 100 pi t applied across an inductor of 2 Henry. Write down equation for instantaneous current. Here it is a single inductor connected to AC supply. Inductance value is 2 Henry and supply EMF 230 sin 100 pi t. We have to find expression for current equals to how much? E equals to given 230 sin 100 pi t. Comparing it with standard equation E naught sin omega t implies E naught equals to 230 and omega t equals to 100 pi t. Now expression for current, instantaneous current, is given by E equals to E naught upon omega L into sin omega t minus pi by 2, because current lags by pi by 2 in inductive circuit. I equals to 230 upon 100 pi, omega value 100 pi into L, that is 2 sin omega t, that is 100 pi t minus pi by 2. I equals to 230 upon 200 into pi sine of 100 pi t minus pi by 2, which on simplification gives 0.36 sine of 100 pi t minus pi by 2. This is required expression for instantaneous current. Example 11. If a coil first connected to DC circuit and after that connected to an AC circuit. When connected to 80 volts of DC, a current of 3 ampere flows through it, and when connected to AC supply of 180 volt 50 Hz, then 2 amperes of current flows through it. Find resistance, impedance and self-inductance of the coil. First, the coil is connected to 80 volt supply and the current flowing through is 3 ampere. In the second case, the coil is connected to 180 volts 50 Hz AC supply and the current flowing through the circuit is 2 amperes. We need to find resistance R, we need to find impedance of the circuit, and we need to find the value of self-inductance, that we need to find the value of L. So what is given? VDC given, VDC equals to 80 volts and IDC given, that is 3 amperes. R value equals to VDC upon IDC, that is a DC voltage upon DC current, 80 upon 3, that is equals to 26.66 ohms. So resistance of the circuit is 26.66 ohm. That is a ohmic resistance. In second case, we have frequency f equals to 50 hertz and we are given Vrms value. Vrms equals to 180 volts and IRMS value equals to 2 amperes. Now being it is a AC circuit, we need to find Z, that is the impedance of circuit, that is nothing but Vrms upon IRMS value. So that is 180 upon 2, that is equals to 90 ohms. So Z value equals to 90 ohms. We have answered the two things. We already got the resistance value, that is R equals to 26.66. We got impedance value, that is Z equals to 90 ohms. Now we need to find self-inductance of the circuit. We also know that the impedance of the circuit is given by under root of R square plus XL square, implies XL square plus R square equals to Z square, XL square equals to Z square minus R square. So XL square equals to Z is nothing but 90. So 90 square, R value 26.66 whole square. So XL square equals to, so we get XL equals to 85.96 ohms. So that is the inductive reactance. We also know that XL equals to 2 pi FL. Therefore 2 pi FL equals to 85.96. Now putting the value of frequency, that is given as a 2 pi 50 into L equals to 85.96. So L equals to 85.96 divided by 100 pi, and 1 upon pi equals to 0.318. This is useful information for the student writing the IIT examination, so they can directly get the value of 1 upon pi, that is 0.318. So 85.96 into 0.318 upon 100. On multiplication we get it 0.27. Therefore the value of self inductance equals to 0.27 Henry. Example 12. A capacitor of 20 microfarad connected to 220 volts 50 hertz supply. Find capacitive reactance and RMS and peak currents. First of all, draw the rough diagram, circuit diagram. Here is a capacitor and connected to AC supply. They not mention AC, but they have given the 50 hertz supply. It indicates it is a AC supply. So it is 220 volts and 50 hertz supply, and C equals to 20 microfarad. So C value 20 microfarad. We have to convert into farad. So multiplying by 10 raised to minus 6. So it is a farad. It is a 20 into 10 raised to minus 6 farad. We have to find capacitive reactance, that is XC equals to question mark, and supply frequency F equals to 50 hertz, and formula for XC, what is XC? Capacitive reactance. So XC equals to 1 upon 2 pi FC. This is equals to 1 upon 2 into pi into 50 into C value 20 into 10 raised to minus 6. That is equals to 10 raised to 6 upon 2 into pi into 50 into 20. That is equals to 10 raised to 3 upon 2 into pi. This is equals to 159 ohms. Therefore capacitive reactance equals to 159 ohms. After that we need to find RMS and peak currents. So IRMS equals to VRMS upon XC. So VRMS given as 220 volts, and we got XC value, that is 159. This is equals to 1.38 amperes. Now we need to find peak current. So this is I peak. Peak current is given by IRMS multiplied by √2. So that is equals to 1.38 multiplied by √2. That is equals to 1.95 amperes. Example 13. If supply frequency is doubled, then find percentage change in capacitive reactance. Do you think will it increase? We have the XC1 initial capacitive reactance, XC2 final capacitive reactance, F1 equals to initial frequency, F2 equals to, that is double of the initial frequency, that is final frequency, and we need to find percentage change in capacitive reactance after doubling the frequency. So let XC1 equals to 1 upon 2 pi F1C and XC2 equals to 1 upon 2 pi F2C. So XC1 equals to 1 upon 2 pi FC and XC2 equals to 1 upon 2 pi. F2 is double of initial frequency, 2F into C. Call it 1, call it 2. Now dividing 1 by 2. So we get XC1 upon XC2 equals to 1 upon 2 pi FC divided by 1 upon 4 pi FC. This is equals to 4 pi FC divided by 2 pi FC equals to 2. So we get XC2 equals to XC1 upon 2, implies after frequency doubled, after we double the supply frequency, capacitive reactance is halved, that means decreases by half. That means the percentage change in the capacitive reactance is 50%. 50%, it is a decrease, therefore decreases by 50%. A 12 microfarad capacitor connected in series with 20 ohms resistor across 220 volts peak value and 50 Hz supply. Find capacitive reactance, impedance and maximum current in the circuit. First of all, let us draw a circuit diagram. We got a capacitor connected in series with a resistor and AC supply, across AC supply 220 volts peak value and supply frequency 50 Hz. We need to find capacitive reactance XC, impedance Z and peak value of current I naught equals to question mark. And we know that capacitive reactance is given by XC equals to 1 upon 2 pi FC, that is equals to 1 upon 2 pi, F is 50 and C value is 12 microfarad. C equals to 12 microfarad, that is equals to 12 into 10 raised to minus 6 farad. So 12 into 10 raised to minus 6 farad, that is equals to 10 raised to 6 upon 2 pi into 50 into 12. On simplification, it gives 265.39 ohms. So we got XC value. After that, we have to find out Z value. Z, nothing but impedance, is given by R square plus X square, that is equals to R value. R value is nothing but 20 ohms So 20 square plus x square, that is 265.39 whole square. So this is equals to 400 plus 70431.85, which is equals to under root of 7831.85. On taking the square root, it becomes 266.14 ohms. So we got the second answer as well, as that is the impedance of the circuit, 266.14 ohms. Now peak value of the current, I naught, that is the maximum value of current, I naught equals to E naught upon Z. E naught given as a 220, so that is E naught, and Z value 266.14, which is equals to 0.82 amperes. Therefore peak value of current, that is the maximum value of current flowing through the circuit, is equals to 0.82 amperes. Example 15. An alternating current of 2 milliamperes with angular frequency of 75 radians per second flows through a series combination of resistor of 15 kilo ohms and capacitor of 0.2 microfarad. Find capacitive reactance, RMS value of voltage, and impedance of the circuit. In AC problem, there are the two types of frequencies. One is a F. F is a supply frequency. Another is a angular frequency, which is nothing but omega. So in this question, omega is given angular frequency 75 radians per second. First of all, let us draw the circuit diagram. It is RC circuit, resistor and capacitor, and connected across AC supply like this. And capacitor value, this is C, and it is R. R equals to 15 kilo ohms, that is equals to 15 into 10 raised to 3 ohms, and the capacitor value, that is C, equals to 0.2 microfarad, that is equals to 0.2 into 10 raised to minus 6 farad. We need to find capacitive reactance, that means we need to find XC, RMS value of voltage, we need to find VRMS, and impedance, that is Z. In previous problem, I had utilized X equals to 1 upon 2 pi FC, but the 2 pi F is nothing but omega. Therefore, another formula for capacitive reactance is 1 upon omega C. So we have 1 upon omega, omega nothing but 75 radians per second, and the value of capacitance, that is 0.2 into 10 raised to minus 6 farads. So when you simplify this, you will get Xc equals to 6.67 into 10 raised to 4 ohms. Now second part, that is we need to find out VRMS equals to how much. The basic relationship, V equals to IR. Therefore VRMS equals to IRMS, and in place of R we will use the XC. Therefore VRMS equals to IRMS multiplied by XC. IRMS value given as a 2 milliamperes. So 2 into 10 raised to minus 3, that is 2 milliamperes, equals to 2 into 10 raised to minus 3 amperes. So 2 into 10 raised to minus 3, and XC value 6.67 into 10 raised to 4. On simplification, this becomes 133.4 volt. Now we need to find out the impedance of the circuit. The impedance of the circuit Z equals to under root of, it is a RC circuit, therefore R square plus X square. R value is nothing but 15 into 10 raised to 3 ohms, that is 15 into 10 raised to 3 whole square plus XC value 6.67 into 10 raised to 4 whole square. Now we will simplify this. When we simplify this can be simplified, especially showing for the 12th student. How will you manage this in examination? Of course, I am not going to show you all steps, but I am going to give you the idea. So I can write here 15 square into 10 raised to 6 and here 6.67 whole square into 10 raised to 8. Now we will take the minimum of this as a common, 10 raised to 6 here, 10 raised to 8 here. So minimum value 10 raised to 6. I can take common here. So it is 15 square plus 6.67 square and 10 raised to 2 is left. Now I can take 10 raised to 6 as a outside of the root. So it becomes 10 raised to 3 and 15 square, that is 225, and 6.67, that is square of 6.67, nothing but 44.49, and square of 10 square is 100. So this is equals to 10 raised to 3 under root of 225 plus 4449 upon 100 into 100, they get cancelled. So this becomes 10 raised to 3 and under root of 4674, this is equals to 10 raised to 3 into 68.36. So this is equals to 68.36 kilo ohms. That is the impedance of the circuit. Z equals to 68.36 kilo ohms. Example 16. A 10 microfarad capacitor, 0.2 Henry inductor, 10 ohms resistor connected in series with an AC source whose EMF is given by E equals to 220 sine 100 pi t. Find first frequency of supply, 2 reactance of the circuit, third impedance, and fourth one phase angle. So let us draw the circuit diagram. Resistor, inductor, capacitor connected across AC supply. Resistor value 10 ohms, inductor value 0.2 Henry, and capacitance value 10 microfarad, and supply given by E equals to 220 sine 100 pi t. We need to find supply frequency, that is F. We need to find reactance of the circuit, that is X equals to XL minus XC, modulus of XL minus XC. We need to find impedance of the circuit and we need to find phase angle. To find frequency, F equals to how much? We have E equals to 220 sine 100 pi t. Comparing it with standard equation, E naught sine 2 pi ft implies 2 pi ft equals to 100 pi t. T gone, pi and pi get cancelled. 2f equals to 100. Therefore, F equals to 100 upon 2 equals to 50 Hertz. So we answered the first question. F value equals to 50 Hertz. Now we need to find out reactance of the circuit. Reactance of the circuit, X equals to modulus of XL minus XC, where XL equals to 2 pi FL equals to 2 pi F value 50 and L value 0.2, which is equals to 20 pi, which is equals to 20 pi. Now XC equals to 1 upon 2 pi FC equals to 1 upon 2 pi, F value 50, C value 10 microfarad, that is 10 into 10 raised to minus 6 farad, equals to 10 raised to 6 upon pi into 1, 2, 3 zeros. So that is equals to 10 raised to 3 upon pi. So that is equals to 0.318 into 10 raised to 3, which is equals to 318 ohms. XL equals to 25 ohms and XC equals to 318 ohms. Now XL minus XC equals to 20 pi minus 318 modulus. So that is 20 into pi value 3.14 minus 318. So that is equals to 62.8 minus 318 equals to 255.20 ohms. XL minus XC difference equals to 255.20 ohms. Now impedance of the circuit, Z equals to under root of R square plus XL minus XC whole square. Z equals to under root of 10 square plus 255.20 whole square. So Z equals to under root of 100 plus 65127. Z equals to under root of 65227. Z equals to 255.39 ohms. We need to find out phase angle. Phase angle is nothing but, for that we use the formula cos phi equals to R upon Z. So cos phi value of R is nothing but 10, Z value 255.39. So cos phi equals to 0.039. Phi equals to cos inverse of 0.039. Therefore phi equals to 87.75 degrees. This is required phase angle. Example 17. In an electronic circuit, a capacitor of 3 microfarad is operating at frequency of 800 Hz and a current flowing through it 2 milliamperes. Find voltage across capacitor. Here the capacitor is equals to C equals to 3 microfarad and this is equals to 3 into 10 raised to minus 6 farad and frequency equals to 800 Hz and we need to find given RMS value 2 milliamperes, that is equals to 2 into 10 raised to minus 3 amperes. Now we need to find voltage across capacitor. For that, voltage across capacitor given by IRMS multiplied by capacitive reactance. Now we don't have the value of capacitive reactance, so first we'll find out XC. XC nothing but given by 1 upon omega C, that is equals to 1 upon 2 pi FC. So that is equals to 1 upon 2 pi, F value 800 and C value 3 into 10 raised to minus 6. On simplification, it gives 66.34 ohms. So capacitive reactance is equals to 66.34 ohms. We want voltage across capacitor. So voltage across capacitor equals to IRMS multiplied by XC. IRMS 2 into 10 raised to minus 3 and XC equals to 66.34. So this on simplification gives 132.68 into 10 raised to minus 3 volt, that is equals to 132.68 millivolt. That is the amount of voltage will appear across the capacitor. Example 18. In an series electronic circuit, if inductive reactance is 4 ohms, capacitive reactance is 5 ohms and resistance is 3 ohms, find phase angle. Here the phase angle is given by tan inverse of XL minus XC upon R, where for phase angle phi equals to tan inverse of XL, that is 4 minus phi upon 3, phi equals to tan inverse of minus 1 upon 3 and phi equals to minus 18.43 degrees. This value you can calculate from log tables. Example 19. A charged 100 microfarad capacitor is connected to 10 millihenry inductor. What is angular frequency of the circuit? Assuming circuit is working as an oscillator circuit. Here the capacitor value given by C equals to 100 microfarad, that is equals to 100 into 10 raised to minus 6 farad, and inductor, that is L, inductance value 10 millihenry, that is equal to 10 into 10 raised to minus 3 Henry. We need to find angular frequency omega equals to how much. Here we are assuming the circuit is under resonance condition. When circuit is under resonance condition, angular frequency is given by 1 upon under root of L into C, implies omega equals to 1 upon under root of L value, that is 10 raised to minus 2, and C value 10 raised to minus 4. So omega equals to 1 upon under root of 10 raised to minus 6 equals to 1 upon 10 raised to minus 3. Therefore omega equals to 10 raised to 3 radian per second. Actually, under resonance condition, L into omega R equals to C into omega R. So omega R, that is omega R is nothing but angular frequency at resonant conditions. So omega R is nothing but angular frequency at resonance. Therefore it is a resonance frequency, resonance angular frequency. Therefore we have omega square equals to 1 upon LC. Therefore at resonance omega R equals to 1 upon under root of LC. Example 20. In series LCR circuit, find voltage across capacitor if applied voltage is 10 volts, voltage drop across resistor is 4 volt, and voltage drop across inductor is 3 volt. From phasor diagram, it is clear that V square equals to VR square plus VL minus VC whole square. VL is 10, so 10 square. VR value 4 square plus VL value 3 minus VC whole square. So 3 minus VC whole square equals to 100 minus 16. 3 minus VC whole square equals to 84. 3 minus VC equals to under root of 84. 3 minus VC equals to 9.16. Minus VC equals to 9.16 minus 3. Minus VC equals to 6.16. VC equals to minus 6.16 volt. Now negative sign of VC indicates VC is antiphase with VL. Therefore, magnitude of voltage drop across capacitor is 6.16 volt. Example 21. Two inductors and one resistor connected as shown in the following circuit diagram. Find impedance of the circuit. Here the inductor are connected in series. Call it L1, call it L2. They are connected in series. So the effective inductance value is equals to L equals to L1 plus L2 if mutual inductance is neglected. Now L equals to, what is the L1 value? 1 Henry, and L2 value as well as 1 Henry. Therefore total inductance equals to 1 plus 1 equals to 2 Henry. Therefore equivalent circuit diagram becomes so L equals to 2 Henry and R value equals to 100 ohms. So it is a plain LR circuit. The impedance of the circuit, here is the frequency given as a 50 Hz. Now impedance of the circuit, Z equals to under root of R square plus 2 pi FL whole square, that is Z nothing but under root of R square plus XL square. Therefore Z equals to 100 square plus 2 pi into 50 into 2 whole square. So Z equals to under root of 100 square plus 100 square into 4 pi square. So Z equals to under root of 100 square taken common, 1 plus 4 pi square. So Z equals to 100 into 1 plus 4 into 9.86. So Z equals to 100 into 1, that is equals to 40.47. Therefore Z equals to 100 into 6.36. Z equals to 636 ohms. Therefore impedance of the circuit